Irodov problem number 1.73. In the arrangement shown in the figure, the bodies have masses m0, m1, m2. The friction is absent. The masses of the pulleys and the threads are negligible. Find the acceleration of the body m1. Look into possible cases. So, we will begin with the diagram first. So, here is this arrangement. So, let me draw the tensions first. So, there will be some tension T, let us say here. There will be some tension T here. This T and this T will be the same tension because this is a continuous string. The tension in these strings will be different. Let us say that is T dashed. And again, both will be T dashed because it is the same continuous string. Okay. Now, let us assume that this is accelerating with A0, this direction. M1, let us say, is accelerating upward with A1 and M2 is accelerating downward with acceleration A2. Now, key thing to understand here is A0, A1 and A2, these are all with respect to ground. Okay. In a pulley arrangement like this, I will use a concept that I previously used in problem number 1.72. It is called constraint motion. So, in constraint motion, the work done by tension forces is equal to 0. So, sum of work done by tension forces, so let us say T dot x is equals to 0. So, which tension forces are doing work? This tension force is displacing m0 by some distance. So, this is doing work. This tension force is responsible for displacement of this pulley, but well, the pulley does not have any mass. So, this one does not do any work. However, this T dashed is responsible for moving m1. So, this one also does some work, and this T dashed is responsible for moving m2, that is also doing some work. Okay. This will be negative work, but we will not calculate the work done. In fact, if I differentiate this once, we can write the same thing as T dot velocity, sum of all those are 0. So, which is, in other words, power generated by tension forces is 0. If I differentiate that one more time, we can write T times acceleration is equals to 0. I am interested in this. Okay. So, let us go ahead and formulate that. So, T times A0, now both are same direction, so both are positive, plus T dashed times A1, again both are same direction, both are positive. However, T dashed and A2 are different directions. So, this is T dashed times A2. So, sum of all these should be equal to 0. So, you got one relation. Okay. Further, if I look at this pulley, there is one tension force like this, and then it is supported by 2 T dashed like this. So, can we write T is equal to 2 T dashed? We are able to write that because this pulley is a massless pulley. So, now we have from these two equations, let us call this 1 and let us call this 2. If I replace T with 2 T dashed, we can write 2 T dashed A0 plus T dashed A1 minus T dashed A2 is equal to 0. T dashed we can cancel out. So, 2 A0 is equal to A2 minus A1. This is an important relation we got. So, we got a relation between the accelerations of each of the masses. Okay. Now let us draw the free body diagram of M0. So we have M0G, some normal reaction, let's say N0. There is a tension here, and M0 is accelerating with acceleration A0. Okay. Let's also draw the free body diagram for M1. So M1, we will have M1G downward. There is tension T dashed. Okay. And M1 is accelerating upward with acceleration A1. Now let's draw the free body diagram for M2. We have M2G. There is tension T dashed here, and M2 is accelerating downward with acceleration A2. Okay. Now that we have the free body diagrams, we can start framing the equations. So T is equals to M0 A0, simple. This tension is responsible for the acceleration of M0 in the horizontal direction. Now this is accelerating upward, so T dashed is more than M1G, so T dashed minus M1G is equals to M1 A1. And from here, M2G is more than T dashed, we can write M2G minus T dashed is equal to M2 A2. Now our goal is to find the acceleration of body M1, which is A1 we will have to find. A1 we will have to find in terms of M1, M2, M0 and G. Okay. So these tension forces, let's see if we can get rid of this tension forces. Now, okay, let's write this equation as equation 3 and this one we will say this is equation 4, 5 and 6. Okay. Now what I can do is let's find out A2 in terms of A0. Okay. So from 4 and 2 we can write 4 and 2. We can write 2T dashed equals M0 A0. Okay. So therefore T dashed is equals to M0 A0 by 2. Okay. Now let's substitute this result in number 6. So we have M2G minus T dash, so M0 A0 by 2 equals M2 A2. Okay. So let's just write 2 M2G minus M0 A0 equals M2 A2, or we can write A2 is equals to 2 M2G minus M0 A0 by 2 M2. Okay, let's use T dashed here. So we get M0 A0 by 2 minus M1G equals M1 A1. So let's solve for A0. So M0 A0 minus 2 M1G equals 2 M1 A1. So M0 A0 is 2 M1G plus 2 M1 A1, or A0 is 2 M1G plus 2 M1 A1 by m0. So I got a0 in terms of a1, I got a2 in terms of a0. This a2 is not very useful, rather if I can do is, what I can do is I can add 5 and 6. If I add 5 and 6, t dash gets cancelled out. So m2g minus m1g, m2g minus m1g is equals to m1a1 plus m2a2. Okay. So if I get a2 in terms of a1, so m2a2 will be equal to m2g minus m1g minus m1a1. So a2 is g minus m1 by m2g minus m1 by m2a1. Okay. So I have a0, I have a2. Now I substitute these results here. So 2a0 is 4 m1g plus 4 m1a1 by m0. Okay, equals a2. a2 is g minus m1 by m2g minus m1 by m2a1 minus a1. Okay, now let's multiply both sides. Let's just simplify this. I will do this faster. Okay, so this is my answer for A1. Okay, so it's a little bit of algebra. That's not the heart of the problem, but really I feel the heart of the problem is this, figuring out the relation between the accelerations. Okay, I just want to put some more insight into this. Let's suppose we were considering this system separately. We try to investigate acceleration of m1 and m2 in the reference frame of this pulley. Let's say pulley B. This is pulley A. Okay. Now, in reference frame of pulley B, which is a non-inertial frame. Why is it a non-inertial frame? Because the pulley B itself is accelerating with A0 downward. Okay. So if I draw the free body diagrams of M1 and M2, how will that look? So M1 free body diagram, we will draw it like this: M1G downward, tension T dashed upward. Now we will have to introduce a pseudo force because we are dealing in a non-inertial frame. The non-inertial frame is accelerating with A0 downward. So the pseudo force will have to apply it upward, which will be M1 times A0. Okay. Now it's as if we are sitting on the pulley and observing M1 and trying to see its acceleration. So in the non-inertial frame, let's say it is accelerating with W1 and this guy is accelerating down with W2. Okay. So W1 and W2 are accelerations with respect to the non-inertial frame. Let me write that down. Okay, so we can write this is accelerating upwards with W1. Similarly, let's draw the free body diagram of M2. So M2G, we have T dashed upwards, and because the frame of reference is accelerating downward with A0, I'll have to introduce a pseudo force M2A0 upward, and then this is accelerating with W2. Now if I write the equations of motion, let me write with this. My apologies, for some reason the recording stopped, but this is how we frame the equations of motions in this case. So T dashed plus M1A0 minus M1G is equals to M1W1. So this is first equation, and from this we can write M2G minus T dashed minus M2A0 is equal to M2W2. Okay. Now just rearranging it a little bit, we can write T dashed minus M1G equals M1W1 minus A0. Similarly here M2G minus T dashed is equal to M2W2 plus A0. Now you will see these two equations are very similar to equations 5 and 6. Only difference is here the A1 was the acceleration of M1 with respect to ground. Here W1 is the acceleration of M1 with respect to the pulley B, but W1 minus A0 will evaluate to A1. Similarly, W2 plus A0 will evaluate to A2. Okay. So this is just another way to solve the same equation. So either you can solve the problem with accelerations as observed from the ground, or sometimes it's easier to comprehend and frame the equations if you get inside the non-inertial frame and then frame your equations, but it can get easier sometimes. But both those approaches will lead you to the same result. Okay, so that is our solution.